So hello everyone, I am Emmanuel Dela Cruz and my other group mate is named Czerissa, Darilay, and we will be going to report to you the symbolic logic and its definition. And we will also give you some examples of symbolic logic. So what is symbolic logic? Symbolic logic, also known as formal logic or mathematical logic, is a branch of logic that deals with the manipulation of symbols. It abstracts logical reasoning from the content of statements, focusing instead on the form or structure of arguments. In symbolic logic, statements and arguments are expressed using symbols and formal languages, allowing for precise analysis and deduction. So, ang symbolic logic po kasi is, dalawang statements po siya and pwede, dito kasi sa symbolic logic, ang isang statement nire-represent siya gamit ang letters. So, I will give you the example of a simple statement that will that can be represented as letters. So, ito ang example ng translation of symbolic form. Sabi dito, let P and Q represent the following simple statements. So, si P, ang simple statement niya is, there is life on Mars. Si Q naman, ang sabi niya, there is life in Europa. So, sa example number 1 ng simple statements, sabi dito, there is life on Mars and Europa. So, kung i-translate natin siya sa symbolic form, ang translation niya is P and Q. Or, yung symbol ng P ay symbol ng N is yung caret. Yung parang arrow na nakatulog sa taas. Yun ang symbol ng end. So, pwede rin siyang, ang translation niya is P, caret, plus Q. So, gets. So, sa letter B naman, another example. There is life on neither Mars nor Europa. Ang ibig sabihin kasi nun, wala daw life sa Mars at saka Europa. So, in symbolic form, ang kanya dito, ang translation niya, not P and not Q. Or, ang kanya dito, ganito ang magiging kanya, symbolic form niya. Yung not P and not Q. Yan po ang example ng translation of symbolic form. Now, the other symbolic form examples will be explained by Czerissa, Darilay.
Symbolic logic uses several symbolic logic symbols called operators, each with its own unique meaning. This includes the following. As you can see on my PowerPoint, there are different kinds of symbolic. First, the meaning of the first one is the universal quantifier, read as for all. Second, the existential quantifier, read as there exists. Third, denoting conjunction, read as and. Fourth, denoting disjunction, read as or. Fifth, denoting implication, read as implies, or when written in the form of P arrow to Q, which we can read is as if P then Q. 6. Denoting by conditional, read as if and only if. Lastly, denoting negation, read as not. The implication P implies Q could either true or false, depending on the initial truth values of P and Q, respectively. The discussion of truth tables in the following section will clarify this notion immensely. One of the symbolic logic key application is transforming an argument in the natural language into symbols to assess its validity and vice versa. For example, the cat will play if he is fed, and he will not play if he is not fed, can be written in symbols if P denotes the statement the cat will play and F denotes the statement the cat is fed. Then P if Q or F implies P and not F implies not P, or F implies P and P implies F. All three are logically equivalent and well-formed. The implication P implies Q. Next, the goal is to convert the following sentence into symbols. For example, Michelle will make dinner if Jack does not, and only if Jack does not as M and Jack makes dinner as J. Then write M if and only if, not J, since the only if part of the sentence indicates a biconditional. Next, the goal is to convert the following sentence into symbols just as before. For example, the economy will improve, the deficit is reduced, but the deficit will be reduced only if government spending does not increase and taxes are raised. It goes this way. If D denotes the deficit will be reduced, E denotes the economy improve, G denotes government spending increases, and T denotes taxes are raised, then the sentence can be converted into symbols. The major components of this complex sentence is the but, which can be logically expressed as N. It is written as D, if then E, and D, if then not G, and T. Okay, let's move on for the truth table. Conjunction of proposition is signified by a dot. Example, Rover is a dog and Felix is a cat. Can be written as Rover is a dog, dot, Felix is a cat, or allowing P to stand for the first member and Q for the second. We can symbolize it by P and Q, both P and Q. The meaning of P and Q is displayed in the following table. As you can see in the first statement, truth, truth to truth is equal to truth. From truth to false, it equals to false. False to truth is equal to false. False to false, it equals to false. The contradictory of a proposition is indicated by prefixing a minus sign to it or by placing an acute after it, as well as in the various other ways. The relationship of contradictories P and minus P to one another as the truth and falsity is displayed in the following table. On this truth of table, they are being opposite. On the first statement, the first is truth, so the opposite of truth is false. Second example, the first is false, so the opposite of false is truth. Next, if two contradictories is true, the other is false, and vice versa. A disjunctive proposition in the broad or inclusive sense is symbolized by a heavy V, the first letter of the Latin word vel, which means or, thus PVQ means P or Q, may be both. This meaning is displayed in the following table. So, for example, truth to truth is equal to truth. Truth to false, it equals to truth. False to truth is equal to truth. False to false, it equal to false. Lastly, try to observe this truth of table. You will notice that PVQ is false only in the last row where both P and Q are false, and that is true in all other stances. In disjunctive proposition in the strict or exclusive sense, one and only one member is true and other members are false. Hence, a disjunctive in the strict or exclusive sense where P or Q but not both is symbolized as follows. P and Q and minus P and minus Q.